Week 3 of Fundamentals of Python and Machine Learning. In this lesson, we are covering Chapter 3, Manipulating Tabular Data Using Pandas, from Python Machine Learning by Wei-Meng Lee. In the previous chapter, we learned about NumPy and how Python can work efficiently with arrays of numerical data. NumPy is powerful, but many real-world datasets do not start as simple arrays. They usually look more like a spreadsheet, with rows, columns, labels, missing values, text, numbers, and categories. That is where pandas become important. Pandas allows to work with tabular data in a way that feels similar to working with spreadsheets or database tables, but with the power of Python. In machine learning, before we train a model, we usually need to load, inspect, clean, filter, and prepare the data. Panda gives us the tools to do that. This chapter focuses on the major idea. First, we will discuss what Panda is and why it is useful. Second, we'll look at the Pandas series, which is a one-dimensional label data structure. Third, we will study the Pandas DataFrame, which is one of the most important structures in data analysis and machine learning. By the end of this chapter, you should understand that a series is like in a single column of data, while a data frame is like a full database with rows and columns. These concepts are important because most datasets used in machine learning are organized as tables. Each row usually represents one observation, record, person, product, transaction, or event. Each column usually represents one variable per feature. Pandas help us organize and manipulate the data before we use it in a machine learning model. A common question a student may ask is, why do we need pandas? We already have Python lists and NumPy arrays. The answer is that the real-world data is usually messy and tabular. For example, a dataset may include student names, attendance percentage, assignment average, login activity, final grades, and pass or fail results. Some columns might contain numbers, other columns might contain text. Some rows might have missing values, some columns might need to be renamed, some records might need to be filtered. NumPy arrays are excellent for numerical calculation, but Pandas give us more convenient tools for working with labels, rows, and columns. Pandas help us ask questions such as how many rows are in the dataset? What are the columns named? Are there missing values? What is the average score? Which students have the attendance below 70%? Which column should be used as features for machine learning? In other words, Panda helps us move from raw data to useful data. Panda is a Python library used for data manipulation and analysis. The name Panda comes from the term panel data. But for this course, you can think of Pandas as a tool that helps Python work with table-based data. Panda is widely used in data science, machine learning, business analytics, finance, education, healthcare, and many other fields. When we use pandas, we can load data from different sources such as CSV files, Excel files, databases, or dictionaries in Python. Then we can inspect the data, clean it, select specific columns, filter rows, calculate statics, group records, and prepare the data for visualization or machine learning. Panda is commonly imported using the statement import panda as PD. The alias PD is the standard convention. When you see PD, you should recognize it that it refers to pandas. Pandas is not usually the machine learning model itself. Instead, pandas is used before we train the model. Think of pandas as a part of the preparation stage. A typical machine learning workflow may look like this. First, we load the dataset. Second, we inspect the dataset to understand what it contains. Third, we clean or prepare the data. Fourth, we separate the features from the label. Fifth, we train the machine learning model using the libraries such as scikit-learn. Pandas help with the first four steps. It helps us take the data from maybe messy, incomplete, or difficult to understand and turn it into a structured dataset that can be analyzed and used for modeling. That is why Pandas is one of the most important tools in this course. Before we can use Pandas, we need to import it. The standard import statement is import pandas pd. That gives you access to the pandas using the shorter name or the alias pd. For example, when we create a series, we write pd.series. When we create a data frame, we write pd.dataframe. This is similar to how we import the NumPy using import NumPy as NP. These aliases are not random. They are common conventions used by Python programmers, data analysis, and machine learning developers. Using the standard aliases make your code easier for others to read. The first major Pandas structure is the series. A Pandas series is a one-dimensional data structure. You can think of it as a single column of data. For example, imagine we have a list of student scores. It is a series of 85, 90, 78, 92. This creates a series with 4 values. A series is similar to NumPy array, but it has something very important, an index. The index gives each value a label. By default, Pandas use the numerical index starting at 0. So the first value has index 0, the second value index 1, and so on. This is useful because we can access values by their position or by their label. A series is important because it represents the building block of data frames. In simple terms, a data frame is made of multiple series placed side by side as columns. Let's look more careful at the series index. If we create this series, Panda automatically gives us an index where 0 is the 85, 1 to 80, 2 to 78, and 3 to 92. The numbers on the left are the index labels, the numbers on the right are the actual values. We can also create custom index. For example, we can define the index property and have different names like Anna, Luis, Maria, and John. Now each score is connected to a student name. This is make the data easier to understand. Instead of just seeing position 0 or position 1, we can see that Anna has a score of 85, Luis has a score of 90, Maria has a score of 78, and John has a score of 92. This is one of the reasons Pandas is more convenient than using plain lists or arrays. When we have a series, we often need to access values from it. If our series has a custom index, we can access values by using the label. For example, scores Anna. This returns Anna's score. We can also use the position-based access, for example, scores iloc 0. This refers to the first value of the series. The word iloc means integer location based indexes. In Pandas, this distinction is important. Sometimes we want to access the value by its label, such as the student name. Other times we want to access the value by its position, such as the first row or second row. This idea will become even more important when we work with data frames. The second major Pandas structure is the data frame. A data frame is a two-dimensional table with rows and columns. If a series is like one column, a data frame is like a full spreadsheet. For example, a data frame could contain student records. Each row could represent one student. Each column could represent a piece of information about that student, such as attendance, assignment, average, quiz average, and final result. This structure is extremely common in machine learning. Usually for each row is one example that the model can learn from. Each column is a feature or a value that helps us describe that example. One column might also be the label, which is the value we want the model to predict. Because the machine learning often starts with a tabular data, understanding data frames is essential. One simple way to create a data frame is from a Python dictionary. For example, we have the follow dictionary with the students, attendance, assignments, and final result. And we can create a data frame from that particular dictionary. This example, each key in the dictionary become a column. The value becomes the data inside each column. The result is a table. The column called the student contains names. The column called attendance contains attendance percentage. The column called assignment average contains assignment scores. And the column called final result contains the outcome. This is a small dataset, but the same idea applies to larger datasets with hundreds, thousands, or even millions of rows. After creating and loading a data frame, the first thing we usually do is inspect it. We need to understand what the dataset contains before we perform analysis or train a model. A common command is head. This shows the first few rows of the data frame. Another usual command is shape. This tells us how many rows and columns are in the dataset. For example, we have 105. That means the dataset has 100 rows and 5 columns. We can also check the column names. with the columns. And we can get general information about the data frame using info. This can show you the columns names, data types, and whenever values are missing. These inspection commands are simple, but they are very important. Before we use a dataset, we need to know what we are working with. Pandas can also calculate summary statistics for numerical columns. One useful command is describe. This gives us statistics such as count, mean, standard deviation, minimum, maximum, and qualities. For example, if we are a column called attendance, the describe command can help us answer questions like what is the average attendance, the lowest attendance, the highest one, how spread are the values. This is part of exploratory data analysis. Before creating visualization of machine learning models, we should understand the basic statistics of our data. If the numbers do not make sense, the model results might not make sense either. When we have a data frame, we often need to select specific columns. To select the one column, we just call it with the column name. For example, DF attendance returns the attendance column as a series. To select multiple columns, we use a list of column names. This will return a new data frame with only those columns. This is important in machine learning because we often need to separate the input features from the label. For example, if we are predicting final results, we might use attendance and assignment average as features. The features are the input values. The label is the value we want to predict. Selecting column is one of the first steps in preparing data for machine learning. Pandas also allow us to select rows. There are two common tools for this, LOC and iloc. The command LOC uses the selected data by label. The command iloc uses select data by integer position. For example, iloc 0 selects the first row by position. If our data frame has custom index, we can use the LOC to select a row by label. For example, df.loc Anna. If Anna is used as an index label, the difference between LOC and iloc is important. LOC focuses on labels, iloc focuses on positions. When the students are new to Pandas, this can be confusing. With practice, it becomes one of the most useful parts of data manipulation. Filtering means selecting rows that match a condition. For example, imagine we want to find a student with attendance below 70%. We can write df's attendance less than 70. This returns only the rows where the attendance value is less than 70. This is called Boolean filtering. The condition df attendance less than 70 that produce a true or false values for each row. Pandas then use those true or false values to decide which rows to keep. Filtering is very important. We can filter students who pass, students who fail, record which high scores, records which missing values, or transaction above a certain amount. In machine learning, filtering can help us understand patterns in the data before we train a model. For example, we might ask, do students with low attendance fail more often? Do higher assignments average usually lead to passing results? Are there outliers or unusual records? Filtering helps us investigate those questions. Pandas also allow us to create new columns. For example, suppose we want to create a new column called at risk. We could write df at risk equal df attendance less than 70. This creates a new column with true or false values. A student with attendance below 70% could be marked as true. A student with attendance 70% or higher will be marked as false. We can also create columns, calculated columns. For example, df's total score equals df's attendance plus df assignments average. This adds two columns together and stores the results in a new column. Creating new column is useful when we want engineer features. Feature engineering means creating or transforming variables to make them more useful for analysis or machine learning. Real-world datasets often contain missing values. A student record might be missing a quiz score. A customer record might be missing an email address. A survey response may be incomplete. In Pandas, Missing values are often represented as not a number, NaN, which means that we can check for missing values using is null. To count missing values in each column, we can write is null.sum. Once we find missing values, we need to decide what to do with them. Sometimes we remove rows with missing values. Sometimes we fill missing values with a reasonable value, such as the mean, median, or zero. For example, df assignment average, fill NA, df assignment average, mean. The correct approach depends on datasets and the purpose of the analysis. This is important because missing values can cause problems when training machine learning models. Most models require complete numerical data, so missing values must be handled carefully. Sorting is another useful data frame operation. For example, we can sort students by attendance with the sort underscore values. This orders the rows from lowest attendance to highest attendance. If we want the highest attendance first, we can write with the ascending equal false parameter. Sorting helps us quickly identify the highest or lowest values. For example, we can find students with highest scores, lowest attendance, largest purchases, or modest values. Sorting is simple, but is very useful when exploring data. Panda also allows to group data. Grouping means organizing rows by category and then calculating a summary for each group. For example, support DataFrame has a column called Final Result, which values such as pass or fail. We can group by Final Result and calculate the average attendance. Group by Final Result, attendance mean. This could show us the average attendance for a student who passed and the average attendance for students who failed. This type of analysis can help reveal patterns. For example, if a student who failed had much lower attendance, that could suggest attendance is related to the final result. Grouping is often used before machine learning because it helps us understand relationships in the dataset. It does not prove cause and effect, but it helps us ask better questions. Now let's connect pandas directly to machine learning. In machine learning, we usually separate our data into features and labels. The features are the input columns. The label is the output column we want to predict. For example, suppose we have this data frame with attendance, assignments, quiz, and final result. If we want to predict whether the student will pass or fail, then final result is the label. The other three columns are the features. In Pandas, we can write x equal data frame attendance assignments quiz average, j equal data frame final result, where x contains the input features. The variable y contains the label. This is a very common pattern in machine learning. Later we use scikit-learn and we'll pass x and y into a model. So Pandas help us prepare the exact structure that machine learning models need. Let's walk through a small example. Suppose we create this data frame. And then we use data frames as data frame with the data. We can inspect the first row with head. We can check summary status with scribe. We can filter student attendance below 70 with the binary checking. We can create our features and we can create our label. This example shows the purpose of Pandas. We use it to organize, inspect, manipulate, and prepare data for analysis or machine learning. Before we finish, let's review some common mistakes students make when learning Pandas. The first mistake is confusing a series with a data frame. A series is one-dimensional, like a single column. A data frame is two-dimensional, like a table. The second mistake is forgetting that column names must match exactly. If a column is named assignments average, then writing assignments average or assignment average will not work unless that is the same column name. The third mistake is confusing LOC with iloc. Remember, LOC is label based, iloc is position based. The fourth mistake is ignoring missing values. Missing values can affect calculations and cause problems in machine learning models. The fifth mistake is changing the data without checking the result. After filtering, sorting, filling missing values, or creating new columns, always inspect the data frame again. Good data work requires checking your results carefully. Let's summarize what we covered in Chapter 3. Panda is a Python library used for data manipulation and analysis. A series is one-dimensional labeled data structure. A data frame is a two-dimensional table with rows and columns. We can create data frames from dictionaries or load them from data files. We can inspect data frames using commands such as head, shape, column, info, and describe. We can select columns, select rows, filter records, create new columns, handle missing values, sort data, and group records. Most importantly, Pandas help us prepare data for machine learning. Before a model can learn, the data must be organized. Panda gives us the tools to organize the data. For this week, your goal is to practice working with Pandas. You should be able to create a series, create a data frame, inspect a structure for a dataset, select column, filter rows, and identify features and labels. As you complete the assignment, do not only focus on memorizing commands. Ask yourself what the data represents. What does each row represent? What does each column represent? Which columns are featured? Which columns could be a label? Are there missing values? What patterns do you notice? In the next chapter, we will move into data visualization using Matplotlib. That means we will make the data we organize with Panda and begin turning into charts and graphs. Panda helps us prepare the data, visualization helps us understand the data, and both are important steps before machine learning.